So let's go ahead and take a look at this next lesson. This next lesson deals with more applications of the derivative. So the first thing to remember is finding the slope of the tangent line. The slope of the tangent line is the derivative at a point. The slope of the normal line is the opposite reciprocal of the slope of the tangent line, which means take the slope of the tangent line, flip the fraction, and flip the sign, either from positive to negative or from negative to positive. When the slope of the tangent line is equal to 0, you have a horizontal tangent. And when the tangent line is undefined, the slope of the tangent line is undefined, you have a vertical tangent. And so there's some illustrations down here. So write the equation of the tangent line to the graph of y equals negative 3 sine of 2x at x equals pi over 2. So the first thing we're going to do is we're going to find the derivative. So you could either write y prime or dy dx. It's up to you. Oops, shouldn't write it in the highlighter. dy dx is equal to negative 3. This has chain rule, so the derivative of sine is cosine. And that's of 2x. And then take the derivative of 2x, which is 2. So dy dx, negative 6 cosine of 2x. So dy dx evaluated at x equals pi over 2 is negative 6 cosine 2 times pi over 2, which equals negative 6 cosine of pi, and the cosine of pi is negative 1, so this is negative 6 times negative 1, which is 6. And that's the slope of my tangent line. To write my equation of my tangent line, I need a corresponding y value to this x value. So y is equal to negative 3 sine. So what I'm going to do is I'm going to plug in my pi over 2 in for my x to find my corresponding y value. So negative 3 sine of pi, and the sine of pi is 0, so this is negative 3 times 0, which is 0. So my corresponding y value is 0. So my equation of my tangent line, y minus 0, is equal to 6 x minus pi over 2. Okay. If the line y equals 6x plus a is tangent to the graph of y equals 2x cubed, find the values of a. Okay, so the first thing I'm going to do is I'm going to take my y is equal to 2x cubed, and I'm going to take the derivative. 6x squared. And it doesn't make any difference whether or not you write dy dx or you write y prime. Okay. The slope of this line is 6, because it's the coefficient in front of x. So that means that my derivative, because that's the equation that represents slope of the tangent line, has to be equal to 6. So I set these equal to each other. So x squared is equal to 1, so x is equal to plus or minus 1. From there, I need to figure out what my corresponding y values are. So y of 1 and y of negative 1. So that's 2 times 1 cubed and 2 times negative 1 cubed. So I get 2 and negative 2. So now I need to figure out what a is. I have now x and y coordinates. I have my plus or minus 1, and I have my plus or minus 2. So that means that at 1, 2, because that's the coordinate point that I found here, y equals 6x plus a turns into 2 times 6 times 1 plus a. So a is equal to negative 4. And then at negative 1, negative 2, my y equals 6x plus a turns into negative 2 is equal to 6 times negative 1 plus a. So negative 2 is equal to negative 6 plus a. So a is equal to positive 4. That means that a is equal to plus or minus 4. Okay. Example 3. Find the coordinates of each point on the graph at which the tangent line is vertical. So the first thing I need to do is I need to take the derivative. Because I have x's and y's on the same side, I'm going to go ahead and use implicit differentiation. So derivative of y squared is 2y, dy dx, minus 2x minus 6 is equal to 0. So I'm going to isolate my dy dx, so 2y dy dx is equal to 2x plus 6, so dy dx is equal to 2x plus 6 divided by 2y. They're all divisible by 2, so dy dx is equal to x plus 3 over y, because I could factor out a 2 out of my numerator. There's a horizontal tangent when the numerator is equal to 0. And my denominator being equal to 0 is my vertical tangent. So, y being equal to 0, I want to find the coordinate points. So that means I need my corresponding y values. I'm going to take my original equation and I'm going to substitute y equals 0 in there. So that means that I get 0 squared minus x squared minus 6 plus 7 is equal to 0. Negative x squared minus 6x plus 7 is equal to 0. I could either factor out my negative 1, or I could just move everything to the other side. X squared plus 6x minus 7. So this factors to x plus 7, x minus 1. So x is equal to negative 7 and positive 1. So then my coordinates are, negative 7 comma 0 and 1 comma 0. Okay. Example 4, write the equation of the normal line to the graph that has a slope of 1/2. Okay. So the first thing I'm going to do is I'm going to take my derivative. Derivative of 2 sine x is 2 cosine x. And the slope of the normal line is 1/2. So this represents the slope of the tangent line. So the slope of the normal line is 1/2. Then I want to change this to negative 2 over 1 to get my tangent line slope. So negative 2 over 1 is equal to 2 cosine of x. Divide by both sides by 2, so cosine of x is equal to negative 1. In the interval from 0 to 2 pi, x has to be pi, because the cosine of pi gives me negative 1. At x equals pi, y is 2 sine of x, so y is 2 sine of pi, which is 0. So my equation of my normal line, I'm going to use my normal line slope, y minus 0 is equal to 1/2 x minus pi. So you're probably trying to figure out, like, why did we do all of this process for example 4? And what we were given is we were given the slope of the normal line, but we weren't given the coordinate point. So remember, when we write the equation of a tangent line or a normal line, you have to have a coordinate point and a way of finding the slope of the tangent and the normal line. Because I wasn't given my coordinate point, I had to go ahead and find it using the fact that I knew what the slope was equal to. Okay. Example 5, find the point on the graph such that the normal line at this point is parallel to this line. So, my derivative is 1 over x. So my normal slope is equal to negative e. This represents the tangent line slope. So to get my tangent line slope, this is positive 1 over e. So that means that 1 over x is equal to 1 over e, cross multiply, so x has to be e. And remember, I'm looking for the coordinate point. So y is equal to ln of x, which means that y is equal to ln of e, which is 1. So my coordinate point is e comma 1. So what did we do here? We found the point on the graph of y equals ln of x, such that the normal line at the point is parallel to that particular equation, which means that I was given my normal slope. I then changed my normal slope to a tangent line slope, and then set it equal to my derivative of ln of x. And then I solve. Once I get my value of x, I then have to find a corresponding y value, and so I take that value, which is e, and I plug it into my original equation. So remember, linearization was using the equation of the tangent line to approximate f of decimal point values. So first write the equation of the tangent line of f of x is equal to x cubed, so f prime of x is 3x squared, and I want to write it at 2 comma 8. So f prime of 2 is 3 times 2 squared, which is 12. So my equation, my tangent line, y minus 8 is equal to 12, x minus 2. And because I'm going to do linearization, I'm going to isolate y here. So y minus 8 is equal to 12x minus 24. So y is equal to 12x minus 16. That means f of 1.9 is approximately equal to 12 times 1.9 minus 16, which is equal to 6.8. And then f of 2.01 is approximately 12 times 2.01 minus 16, which is equal to 8.12. So f of 1.9 is approximately 6.8, and f of 2.01 is approximately 8.12. So now looking at example 7, f is a differentiable function, f of 2 is equal to 6, f prime of 2 is equal to negative a half. Find the approximate value of f of 2.1. So I'm going to write the equation of the tangent line, but what you notice is that I was given the tangent line slope, and I was also given the coordinate point. So the equation of the tangent line, y minus 6, is equal to negative 1/2 x minus 2. And then I'm going to go ahead and I'm going to isolate my y. So y minus 6 is equal to negative 1/2 x plus 1. So y equals negative 1/2 x plus 7. So now f of 2.1 is approximately equal to negative 1/2 times 2.1 plus 7, which is 5.95. So f of 2.1 is approximately f of, or 5.95. Example 8, the slope of the function at any point is given by this equation. That means that dy dx is equal to this. At the point 3, 2, or the point 3, 2 is on the graph. Write the equation of the tangent line at x equals 3. Use it to approximate f at 3.1. So, dy dx, we're going to first evaluate this at 3, 2. Negative 3 plus 1 divided by 2, so I get negative 4 over 2, which is negative 2. Write the equation of the tangent line. So y minus 2 is equal to negative 2, x minus 3, y minus 2 is equal to negative 2x plus 6, y equals negative 2x plus 8. Part B is to find f of 3.1. So negative 2 times 3.1 plus 8, which is equal to 1.8. So f of 3.1 is approximately 1.8. And now we're going to get into some physics stuff. Slope is a rate of change. Your average velocity is the change in position over the change in time. Your instantaneous velocity is the derivative. Velocity can be positive, negative, or 0, but the speed of an object is defined as the absolute value of velocity. Similar to average velocity, we can calculate average acceleration, which is the change in velocity over the change in time. And then regular acceleration is the first derivative of velocity or the second derivative of position. Remember this table. When velocity and acceleration are both bigger than 0, the speed of the particle is increasing, or when they're both negative. Did I circle the right one? No. When they're both negative, speed of the particle is increasing. Speed of the particle is decreasing when velocity and acceleration are going in opposite directions. So one is bigger than 0, one is less than 0, or vice versa. Okay. So, example 9. The position of the particle moving in a straight line is given by the function. Find the position, instantaneous velocity, acceleration, and speed of the particle at t is equal to 1. So, s of 1, 2 times 1 cubed, minus 10 times 1 squared, plus 5. So, s of 1 is equal to negative 3. B, instantaneous velocity. Take the derivative of position. So v of t is equal to 2 times 3t squared minus 10 times 2t, and then the 5 goes away. So v of t is equal to 6t squared minus 20t. So v of 1, 6 times 1 squared minus 20 times 1. So v of 1 is equal to negative 14. Part C, acceleration. Take the derivative again. So a of t is equal to 6 times 2t minus 20. So a of t is 12t minus 20. So a of 1 is 12 times 1 minus 20, which a of 1 then is negative 8. Speed of the particle is the absolute value of velocity. Which is positive 14. So now let's take a look at example 10. The graph of the velocity function is shown in the figure below. What is the acceleration when is acceleration equal to 0? Acceleration is equal to 0 when v of t has horizontal tangent lines. V of t has horizontal tangent lines at t is equal to 1 and 3. So the acceleration, and this is because I'm on v of t graph. So acceleration is 0 at t is equal to 1 and t is equal to 3. Then when is the particle moving to the right? The particle moving to the right is when v of t is bigger than 0, which is above the x-axis, so on the interval, two to 4. And then c, when is the speed the greatest? Well, when I look at my velocity graph, so speed is the absolute value of velocity. So I have two candidates, my v of 3 or my v of 1. My v of 1 is equal to -4, but the absolute value -4 is 4. And then my v of 3 is 2, so the absolute value of 2 is 2. So my speed is the greatest at t is equal to 1, because that represents the absolute value of velocity. 11. From the 400-foot tower, a bowling ball is dropped. The position function is given by the function below. Find the instantaneous velocity of the ball at 2 seconds, average velocity for the first 3 seconds, and when the ball hits the ground. So A, instantaneous velocity, take the derivative. So v of t is equal to -32t. So v of 2 is equal to -32 times 2. So v of 2 is -64 feet per second, because this time we have units. B, to change colors. Average velocity. So the average velocity is the change in position, so s of 3 minus s of 0 over 3 minus 0. So change the position over the change in time. So -16 times 3 squared plus 400 minus -16 times 0 squared plus 400 all over 3. So your average velocity, when you do the arithmetic, will give you -48 feet per second. When will the ball hit the ground? Ball will hit the ground when the velocity, or when the position is equal to 0. So 0 is equal to -16t squared plus 400, so -400 is equal to -16t squared, so 400 is equal to 16t squared, divide both sides by 16, so 25 is equal to t squared, so t is equal to plus or minus 5, but t has to be bigger than 0, no negative time, so t is equal to 5 seconds. Okay? And that is it for this lesson.